Hello bachon, today we will learn about optical instruments from our Unit 9, Ray Optics. Now I know this is a very important topic and some of you might find it a little bit scary, but trust me, we will make it super simple and completely exam safe. So there is absolutely no need to be scared.
Okay, so let's start with a simple question to get our minds working. I'm sure we've all seen this, right? In movies and cartoons, the detective is always holding a magnifying glass. But have you ever stopped to think? How does it actually make things look so big? What's the secret?
Well, this magic is what we in physics call a simple microscope. And let me tell you, if you understand this one simple idea, you'll understand all the other optical instruments too. So let's dive right into it.
Think about it. To see something clearly, what do? We bring it closer, right? But there's a limit. Go on, try it now with your finger. Bring it closer, closer. See? At some point, it becomes blurry. Our eye just can't focus. This closest distance, Joe, has a special name, the near point, which we call D. For a healthy eye, it's about 25 centimeters. So the real problem isn't that the object is small, it's that we can't bring it any closer than this near point to see it properly.
Okay, so now watch this. This is where the magic happens. On one side, you have the object at the near point. See that small angle it makes with the eye? Now, on the other side, we introduce a convex lens. This lens is a game changer. It bends the light, creating a much bigger virtual image. And because of this, we can bring the actual object way closer than our 25-centimeter limit. The result? Look at that angle now. It's so much bigger. Our brain interprets this bigger angle and tells us, wow, that object is huge.
So this brings us to the most important concept here, angular magnification. You see, it's not about how big the image is in centimeters. It's about how big it appears to be. It's all about the angle. It's a simple ratio, the angle you see with the lens divided by the biggest possible angle you could see without the lens. This magic number is what tells us the true power of the microscope.
Alright bacho, pens out, note this down very carefully. This is the exact NCERT formula you need for your exam. For a simple microscope, when the image is at the near point, the magnification M is equal to 1 plus D by F. Remember, D is our near point, 25 centimeters, and F is the focal length of the lens. This formula is your best friend for solving numericals, okay?
So, let's look at this formula. What is it telling us? To get a really big magnification, a big M, what do we need to do? We need to make that F in the denominator as small as possible, right? It's simple math. A lens with a short focal length is, well, it's fatter, more curved, it bends light much more aggressively. And that's what gives us that high magnification. So for your exams, just remember this one simple thing. Small f means big power. Simple. Now, a simple microscope is great, but it has its limits. You can't really get more than, say, 9x magnification before things start getting all blurry and weird. So to see really, really tiny things, like cells or bacteria, we need an upgrade. We need to go to the next level. And that, my friends, is the compound microscope.
So what's the big secret? It's teamwork. Instead of just one lens doing all the work, the compound microscope uses a team of two. The first one, which is right next to the object we're looking at, is called the objective lens. And the second one, the one our eye looks through, is called the eyepiece. It's a two-lens system.
Okay, so how does this team work? It's a brilliant four-step process. Pay attention. Step 1. The objective lens takes the tiny object and creates a magnified, real, and inverted image. Then, step 2. This new image becomes the object for the second lens, the eyepiece. You see? The output of the first lens is the input for the second. In step 3, the eyepiece just acts like a simple magnifier, like the one we just learned about. And in the final step, it takes that intermediate image and magnifies it even more to give us the final, super magnified, virtual image that we see. It's magnification on top of magnification.
Okay, now for the numbers part. Don't worry, it's not complicated at all. So, how do we figure out the total power of this amazing two-lens system?
Believe it or not, it's super simple. The total magnification is just the magnification from the objective lens multiplied by the magnification from the eyepiece. That's it. You just multiply the two powers together. It's like a power-up on top of a power-up.
Okay, here is the exam-safe formula you absolutely must remember. The total magnification, M, is approximately L by FO multiplied by D by FE. Now what are these terms? L is simply the length of the microscope tube. FO is the objective's focal length, and FE is the eyepiece's focal length. It's a really powerful and easy formula to use.
Okay, talk is cheap. Let's try an example with some simple numbers, just like you'd find in your textbook, to see just how powerful this thing is. Let's say the objective focal length is 1 centimeter, the eyepiece is 2 centimeters, and the tube length is 20 centimeters.
So let's plug those values in. We get m is equal to 20 divided by 1 for the objective part times 25 divided by 2 for the eyepiece part. And what does that give us? A massive 250x magnification. Can you believe it? That's the power of putting two lenses together.
Chalo, now for a very important section. This is where students lose marks. We're going to talk about the silent killers, the common mistakes and traps in exams. Let's make sure you don't fall for them.
Okay, two things you must burn into your brain. Mistake number 1. Students write that the final image is real. No, the final image is always virtual. The intermediate one is real, but the final one is virtual. Here's a trick to remember. The eyepiece makes a virtual image for your eye. Got it? Mistake number 2, thinking bigger lenses mean more magnification. It's the complete opposite. To get high power, you need short focal lengths, small FO and small FE. Remember that.
So, let's quickly summarize everything we've learned today. This is your quick revision checklist before the exam.
Okay, here are the 5 key takeaways you absolutely must have in your notes. First, a simple microscope works by increasing the angular size. Second, a compound microscope is a team of 2 lenses, an objective and an eyepiece. Third, the objective lens forms a real, inverted, and magnified intermediate image. Fourth, the eyepiece then acts on this image to form the final virtual image. And finally, the total magnification is just the product of the two, m equals mo times me. That's it.
All right, so we've just mastered the micro world. We know how to see the tiny things. But what about the other extreme? What about seeing things that are very far away, like the stars? How do we build an instrument for that? Well, get ready because that's our next topic, the telescope.